testing. Let me pull up. Hello, testing. All right, cool. All right, so I'm gonna do some more LeetCode problems. Let's see how that goes. Image overlap. You are given two images. Image 1 and image 2 represented as binary square matrices of size n by n. A binary matrix has only zeros and ones as values. We translate one image however we choose by sliding all the 1 bits left, right, up, and or down any number of units. We then place it on top of the other image. We can calculate the overlap by counting the number of positions. We have a 1 in both images. Now that a translation does not include any kind of rotation, and any 1 bits that are translated outside the matrix borders are erased. Return the largest possible overlap. Okay. So we have two 2D matrices, and then we can translate the so what's the max output we can get if we were to um, translate it exactly as we're, yeah, not which translation um, would do it, but what's the max that we would get out of the best translation, right? So, like what? So when we get an overlap, so basically we want to test um, like every possible, because if you move all of the ones out of the square, you're not gonna get any like good overlap, obviously. So you could test everything. You could test like up to. So if you move this 1, 2, 3, once you've shifted, yeah. So at most, you want to shift up 2 units, right? So you want to check, and then basically, yeah. Then we just want to like and them. So, um, so we'll check if for shifting it up, no units will overlap 1 unit what the overlap is. Shifting it up 2 units what the overlap is, and then we'll do the same with what is if like standard to the right, or yeah, we'll do just the standard overlap first, like what it is if with no translation. Then um, if we shift it 1 unit to, if we shift everything 1 unit to the right, if we shift everything 2 units to the right, and then so on and so forth with all the other ones. Because if you shift it Like if you went 1, shifted up 1, then 2, then 3, then it would just be off, and then off, like, even at the very bottom, if you shifted it 3 units, it would just be off of the image. So then it's not gonna give you anything. So just um, so I guess what we could do is like the first, like doing it, breaking it down into smaller pieces. We could do a function. We could do a function whose job is to take the two images and add them together and then return what that would be. And then we can have a function that translates an image a given number of units. But so we'd have to tell it um, we we'd have to give it two parameters, or probably the best way to do it would be to give it like two parameters to say like how much do you want to translate it on the x, how much do you want to translate it on the y. Um, so that way we can just say like if we want to translate it left, we'll just give it a negative 2 units in the x position. And that way if we wanted to, so it says um, oh, we do yeah, especially because we do have to check, we don't only have to check uh, up 2 units, to the right 2 units, to the down up to 2 units, and we need to check all the diagonals too. Like if we shifted it to the right 1 unit, or you could even do like to the right 2 units and down 1 unit. So that's there's a few to check. So we could do so ultimately it's yeah, you could probably like, I think we'll probably do loops, like loop it um, for every x translation, every possible y translation. We'll just do like a little nested something. Um, so let's see. So let's break it down into pieces. Is I think the best way to do it. Um, so we'll do those two functions first, test them, and then from there, then we'll build um, the logic to test every combination of or every translation. So we'll go make a new file, and we'll make a function, and this is going to be matrix and it's going to take the 2D matrix. So we'll call it matrix, matrx. And it's going to take, oh, it actually needs, say matrix 1 and matrix 2, because we want to take the two 2D matrices or matrices and them, and then return what we would get if we ANDed them. So we'll go ahead and we'll have so we know we're gonna have that these are gonna be, are these always, no, it's n by n, so it could be um, they're going to be square matrices, but it could be any size. So we'll say that for row in mx1, and then so we'll have a I think I did this before. I think you can do, so if I want to start with just what I think I want to do is I want to start with a empty matrix, or I want to fill a list with empty lists, but I want it to be the size of, I want all the rows to be there to begin, like empty rows to be there to begin with, and then I just want to like fill them up. So um, what I'm thinking is what I'm going to do is go like, I think you can do let's say x equals 4, and then rows is equal to and then I think I go like now I want to like just append a bunch of empty lists. Or or I meant to do like times x actually there, but that doesn't, that's the same difference. Did I do that before? I did something like that before, didn't I? Let's see, Python apply empty lists. Isn't that what I just did? Oh, do you have to have something in it? Is that what the... Was... So it does do that. But oh, can I do rows is then actually then could I do um oh, okay, perfect. That's exactly what I wanted. All right. Yes. So that's what I want. So I'll do so we go back to here, and So then we say result equals times length of mx1. So then we have empty rows, and then for every row, actually we want the index too. We're gonna need the index of it, so we're gonna say I equals 0. I'll say for I in range length of mx1. Then then we're going to say j equals 0. And then for j in range, length of mx1 at 0. So how long the inner, which actually it should be the same. So I probably wouldn't even need to do that, but I could probably just get the length once. So why don't we do that? We'll say, because I'm getting, how many times have I gotten the length now? That's 3 times. Even though it's not like expensive, it would make sense just to go like at n equals length of mx1 and then just use n for all of this, because n is the same over and over again. So we go times n. Yeah, it also just makes it easier to read, right? Also, we don't need this, right? Because we're doing in range, so we don't need to do that manually. It's going to do the for. So we'll go for I in range n, and then for j in range n. So for every row and every column, if mx1 at, because it's going to be 1 or 0, so like let's say x equals 1. You say x, or no, bool x, true. Or say, like let's say if, anyway, I know it's going to work. If mx at, if mx1 at, we're going to go at I, j, and mx2 at I, j, right? Then we want to do result at I dot append, and we're going to put, these are integers, ones. We're going to append a 1 there. Otherwise, we need to append a 0. Alright. Alright, so yeah, that's good. And then we just want to return the result. We'll go return result. And then, so, right off the bat, if we were to and these two together, um, without any shifting whatsoever, then we would just have the middle because um, the only place where they are both in the same place is that middle square. So we could use this as a test and see if it works. So we'll go F5, run that. We'll say um, say M1 is this. M2 is this one. And then we'll say that's not right. What just happened here? Must be there's a logic error here in range. It's a logic error here. We have let's check it on Python tutor. So basically just do this. Alright, so it's going around. We got those. Makes sense. So now we're alright, now that makes sense. Wait, no. I is 1. Oh, wait, what's going on here? Why are these... These are all pointing to the same... Okay, so that doesn't work. This is not what I would... You made 3 references. Yes, that it does appear to be what I did. Doesn't it? That does appear to be what I did. How do I do it not like that? How do I do a copy? 3 copies? I just wanna what as how bad? I don't think it would be like I think I can just go like um uh result is like that, and then we'll go for we'll say for I or in range n result append an empty list, and then do that. Same thing again. Cool. All right, so that works now. So now we need to do next step on the incremental development of this. What we want to do is do a function to translate the matrix given number of units in the x direction and a given number of units in the y direction. She'll do that in just a moment. Be right back. I gotta use the bathroom. We'll be right back. Now I think about it, with the matrix, and I think what I might end up adjusting that just a little bit so that um, instead of having it return a result, I might just have it like keep a count. Yeah, because that'll be more useful ultimately. So it'll do exactly what we need. But so if I go instead of this, so we could just say like instead of returning a result, what we want to do We won't do any of that. We won't do this. We won't do that. We don't even have an else really. We'll just say count at 0. And we'll just say count plus equals 1. So this, say return count. So then, if we ANDed these together, we should get 1 now. Huh? Oh, because of the else. We'll say no else anymore. So goop. Good, okay. So that'll be good for that. And then what we want to do is do a matrix translate. So then we'll move so basically, yeah. So we'll want to do all the possible translations and all the possible ands, and then just whichever one ends up being the biggest is what we return. So we go nation matrix translate, and then we'll say how many x units we want to translate it and how many y units we want to translate it, and then we'll say while x, we will okay, that is true. So if we have a negative number, it is true. We'll say, we'll just do this. While x is greater than 0. Because if it's less, while it's less than 0, we'll do it the other way. While it's greater than 0, then what we want to do is that means we want to move it to the right. So what we'll do is put a 0 on the front and then pop off whatever's on the end, right? So we'll go and we'll do that for every row. So we'll say for row, and we need the matrix. Obviously, so we need the matrix and we need how many x units, how many y units. So we'll say for row in matrix, we want to go row dot insert the index then element, right? Python list insert. Yes, index and then element. So we'll go so at the front we want to put a 0. And then we want to go row.pop, just take off the last element. Alright? Then we'll go x minus equals 1. And then we'll say then, so that's all translation. And we'll say left translation while x is less than 0 for row in matrix. We want to row dot pop 0. So we want to take off the first element. And we want to append an element. We want to append a 0 at the end. So that'll move everything to the left. I mean, yeah. Yes, that will move everything to the left. Pop the first elements off of every row and then append a 0 to the end of each of them. So then we'll go x plus equals 1. Then we want to do up translation and down translation. Up translation while y is greater than 0 for, okay, so then how do we want to do this? This one's a little bit more, so we got to so basically then we need to take off the top row and then make a row of just zeros on the bottom, right? So then we say we'll say mx dot pop 0, right? And then okay, so that works. And those definitely aren't references, so I can do that. N equals length of mx. So we're going to take off the first row, and then we're going to go mx dot append, because this is going to move it up. We're going to take off the first row, and then we're going to put on the end just a row of zeros. So we'll go append 0, row times n. Right? And we're going to go y minus equals 1. So do that as many times as there are y things to do. And we'll do down translation. It's going to be while y is less than 0. We'll go ahead and put a row of zeros at the top. So we'll go mx dot insert at 0 a row of zeros. 0 times n. And then we just want to do, then we want to take off the last one. So we'll go mx dot pop. And we'll go y plus equals 1. So we can test that now. Should be fairly easy to test. We'll just say take this one for example. Looks like that. And let's do matrix trans. Let's do it just like the example there. We'll say we'll translate it to the right by 1 unit and down by 1 unit. So it would be m1 to the right by 1 unit would be 1 unit, and down by 1 unit would be -1. I forgot to have it return anything. Does it affect the... Oh, it did. It did change it, though. It changed it. And it did exactly what it should do. Perfect. Perfect, perfect, perfect. But we'll have it return it as well. We'll just say return. Oh, we don't want to do that, though. Actually, we don't want to... what we'll do is we'll just... how about we do it like we don't want to affect the original one because we're going to want to reuse it. Yeah, we're going to want to reuse it. So we don't want to affect it in place. What we're going to want to do is go like yeah, I can go mx equals copy, or is it matrix dot... Oh, but is it gonna, are they still gonna be references to the original? Or, because I need to like deep copy, right? I need to go like for everything, I need to copy. You know, I'm not quite sure if I need to. So if I don't, okay, so if I don't, I could just not pop stuff off the end, but that way, like, I could just switch it back, but doing a whole bunch of deep copies is probably gonna be not very efficient. But well, we kind of have to do it though, right? So we should say like this is probably the easiest way to do it, right? Row dot copy. I'm not using NumPy for it. Shit, this is overkill. I feel like we're gonna go row dot copy. That should work. So we'll just make a, so then, yeah, we're just basically copying into a new matrix so we don't affect the original one. So that now we'll go return mx, and we can test it. Say m1 is this. Do this. And what we get is that, which is what we had for M1, but now when we do M1, our M1 is still what it was originally. We haven't changed M1 now, which is what we want because we want to run every possible translation on M1 and then and it against M2, right? So we're almost there. We've got we've got the building blocks. So we have this. We can just basically copy and paste this in now. So we've got our anding our matrices together, and we get the count and then the translation. So the largest overlap, we're gonna say we're gonna try every translation. So for every x translation, every possible x translation is -2 to 2, right? So for every possible x translation, -2 to 2, we gotta try every y translation from -2 to 2, right? So range is inclusive to exclusive, right? So it could go like from range, like if we go range -2, 3 should give us what we want, right? like this. Right. Yes. So we'll go like largest equals 0. We'll say for I in range -2, 3. And for j in range -2, 3. We'll say count equals, we'll say mx translated is going to be, we're going to go matrix trans, and the one that we're going to do translations on is image1. Really, we could do it on either one, but we'll just do it on image1. And then we'll do I and j. Right? So for every I value, for every I possible I translation, we'll try every possible. For every, or we could call those x and y. It would probably make more sense to call them x and y. Yeah, let's just call them x and y. It makes more sense anyway. So for every possible x translation, we want to try every possible y translation. Right? Every possible shift we could do for x, we want to see if we shifted it. Yeah. All right, that makes sense, right? So then what we do is if, then we want to go count equals mx trans, or we want to do the and. We want to do matrix and, say mx trans and image2. So this new this translated image, and included in that is going to be the 0, 0. At some point, one of those is going to be no translation, right? So we will and it with image2, and if count is greater than largest equals count. And then we will return the largest. All right. Cool. So yeah, let's see if that works. Cool. So the trivial case worked. Let's see if it works in terms of expected 1. So why would this be the case? So we have one where it's the top right, and then we have one where it's the bottom left, right? So let's try something. matrix and then that. And I got let's try this. Don't need to tell it that. So then we're using these. This is so why would that take so why would that be so many steps anyway? I guess yeah, it kind of makes it would be. Should I do the? No, I mean it shouldn't be that bad, right? Or a translation that I could do is I could do like the. There's a faster way to do that, but or there's a fewer. It's not really. It's fewer steps. I don't know how much faster it is really, but it's definitely it would be fewer. But the thing is though, the thing is it's never gonna get translated more than 2 units, so it's not gonna save that much time. Like, or no, it definitely. Oh yeah, no, because these aren't all 3x3s. Never mind. I'm thinking, yeah, I'm thinking as if it's always gonna be three, but they're clearly not. What if? Okay, let's do a smaller case here. Let's do if it was. Um, let's do like a 3x3. 1, 0, 0, and then 0, 0, 0, 0, 0, 0, and then same thing, but just here. So top. So the same idea. It should end up being 1, because if you moved it all so that the top left met the bottom right. Is it really taking that many steps to do this for 3x3? Let's try it on. Do I get the right answer if I go in here and do it here? Largest overlap, 5. No, that works. Yeah, that works. So why would I not get it for that? Or no, it was top right and bottom left. Top right and bottom left. For some reason, that missed. Alright, so if M1 was like that, and M2 was like that, and then we did it. No, that works. That works. What about for the test case that I just did? So copy that, notepad, say here M1 equals this. And M2 is this. Not. So why? How could that possibly? Do I have it hard coded as 3 somewhere? Oh, you know what? Yes, I do. I do have it hard coded. I have it hard coded. That's why I have it hard coded from -2 to 3, and it shouldn't be from -2 to 3. It should be from negative length. Right. Okay. Yes, that makes perfect sense. So say n is length of image 1. Right. And then we'll do this from -n to n plus 1. And then from -n to n plus 1. Right. And then we'll hope that that it works for time complexity, but I wouldn't be surprised if it doesn't. We'll see. There's a slightly faster way to do the translations, maybe. We'll see if I have to do it. Time limit, right? It passed all of them, but took too long. Okay. Okay, fair enough. So there's, I think what we could do then is what we could do is shift. So instead of, for every to get the steps lower, to get the number of steps lower, instead of decrementing by 1, what we could do is we could go ahead and do some list splitting, maybe. Or I remember doing this when I did like a rotate list thing, where like if you take however much you're going to shift it, or actually we don't even need to do that, right? Because that's that's overkill for what we're trying to do. This could be all we would really need to do. So the rows, well, Right. So we could do is just do like list splitting, where like if we need to up translate more than one, instead of popping those all off individually, we could just say um, for X is probably more important even. Um, so we're going through every row there and doing that. What we could do is say however many we're going to split, we could go like from, okay, so say we have X, right? We have X is this. X is 1, 0, 0. And we want to go flip, we want to shift it over 2 units. So what we could go is X equals so if we wanted to go 2 units, we tell it to go from 2 onwards. So if this was, if we wanted to shift it over, this would be if we wanted to shift it over 2 units to the left. If we wanted to go to the right, then if we wanted to go, so that would be, what? Oh. Oh, so say X, so this would be if we wanted to shift things to the left, right? We go 2 onward plus whatever, so say XL, be like that. X2 onward. Be just like that last element. But if we wanted to go from the right, you could go XR equals X from beginning to would it be -2 like that? Oh, did I just do X2? Yeah, so then that would just get the first L. So we want so that'll be like N, right? And then we could say then we want to just append. So then we would just append however n many zeros, right? So that for the left one, we would just put the 0, since it's going to the left, we put the zeros on the back, and then on the other one, we put the zeros on the front because that's going to the right. So so then we could go like X2 equals 2 times 0 plus X2, right? And then we go X2 is now looking like that, right? Which would be moving it to the right those units that we need. So let's try that. Let's try doing something like that. So we could go and I'll just comment this stuff out. So it's going to be really similar, right? We're going to go for a row, we're going to go for row, what we want to do is going to say row dot so we'll say row equals row from X onward. Wait, right? Doing it right is no. Right is the other way. So we go negative X, right? And then we want to go row equals, or say, actually we could do it in one line here. Row equals X times 0 times, or plus that, right? So that's good. And then we'll say left is going to be similar. Right? So for row and matrix, instead of this, we're going to go row equals row from X onward. And plus X times 0. So those all those zeros. And it's the left one. Now as far as up and down, what can we do? As far as up and down, it might actually be easier even. So if you do up and down, what you want to do is say, so if you have a 2D matrix right? Like the let's say mx equals this, right? So if we have a 2D matrix like that, and we say we want to shift it up y units, and we say so we say we want to shift it up 1 unit, then we could say mx equals mx from 1 onward plus 0 times length of mx at 0. All right. Good. Okay. So it'd be up. So up translation, let's just say, it's so different, I don't even need to copy. Translation, we say mx from y onward, and mx equals mx from y onward plus 0 times n. Right, we got n, didn't we? Yeah. So that'll extend that. And down translation, mx equals mx from the beginning to negative y, and we're gonna just go, or actually shit. Oh, times, we'll just do times y here, and then yeah, okay, perfect, because that's how many rows we need to put on. So we can do that plus 0 why are you doing that? Okay. 0 times n times y, except it's not going to be on the back, it's going to be on the front. Because if it's going down, it's got to be on the top. So we'll go cut that, put it on the front. Right, cool. All right, no insert. Wait, what do I have insert on? There we go. It should be of mx. No, this should be of mx. There, yeah. There you go. And yeah. Okay. That should be faster. There should be less steps, because for big matrices, that would it would be bad to loop through and pop every single one we need to shift over. Instead we just split it. I think it should reduce it. Okay, but let's see if it works. If I didn't break it. Wrong answer. Is that the standard test case? Uh, so I must have broke the translation somehow. It's not working for some case. It worked for a surprising amount of them. It's a little worrying. That means it might be hard to find what's causing the problem. Right. What could be causing that problem? Yeah. So you need to put that many rows on, yeah. That makes sense. Because you need to put, yeah. So that'd be how many rows you'd put on, and that'd be how, like how many would be, how many zeros would be in each row would be n. Right. Seems like it should be. That's the, this is the, okay, I don't know, it's like, it's saying all these pass, but this is the trivial test case. It's the same one. It's the same one that you do when you hit run code, right? Huh. Let's try. Let's do the. Let's throw it in Python tutor again. Because now it should have. Actually, now it should actually run in here because the steps won't be as nightmarish. So we could go. Where is it? Um, we need to overwrite that or just overlap on here. Right. And is fine. We didn't change that, but we did change. We want now. We want to change the translation. So we have that. Where did where I got it right here? Here. Matrix translation. So let's see. Let's watch this go. Let's see how it goes. So what is the problem now? Visualize. Register overlap. Okay. So we want to move 3 to the left and 3 down. Okay. Which actually, we're doing too many, like that, we don't even need to do that many, right? Like, because if I move over 3, it's not gonna, So I could save some steps here, like a couple, at least. Wait, what? Where are we? Right here. So we do the oh, you know what? We only want to do that if it's right. No, that would that would explain a lot, wouldn't it? We only want to do that if x is positive. We only want to do that if x is negative. We only want to do that if y is positive. We want. Okay. I think I see what the problem is. So say if x is greater than 0, then we'll do this. If else, or no, we don't want to do else because then if it's 0, it'll still run. So we'll say if x is less than 0, then we want to do this, right? And then if y is greater than 0, then we want to do this. If y is less than 0, then we want to do this. All right. Okay. Okay. That's right. It's really still? Really still why? Okay. Well, we'll make the change on here too. So say if x is greater than 0, if x is less than 0, if y is greater than 0, if y is less than 0. Okay. So then, yeah, you row at three. Right. No, that makes sense. Huh? Oh. Yeah. Need to. Huh? Okay, so that's there. Why would this be so many steps anyway? Um, let's do we could make it a little bit less steps by just going. There's one less than we need to do. Or we can do one less, right? We can go n. As far as the translates go. Or ranges, yeah. Negative n plus 1 to n, right? That's all we need to do. So save. Not very much. It doesn't make that much of a difference. Why is there so many fucking steps? So yeah. So we want to start moving left 2 up to, but not including, yeah. No, yeah, that makes perfect sense. So we want to try that. We want to try negative 2, 2. 4 row in matrix. So we've got this new one. Alright. And we're just copying everything over. And then we're going to do the left translations. We want to go, row is, so we're on the first row first, is here. We're going to do that. And what it should do is move it over left, so it should just make it zeros, right? So what's the one that we're expecting it to give us 3 on? The one we're expecting it to give us 3 on is moving right 1 and down 1, right? Should give us 3. So why wouldn't that give us 3 when we get there? When we go right 1 and down 1, we would have x is 1 and y would be negative 1. So where's we go x. Okay, so x is 0, y is negative 2, so it should be pretty close, right? X is 0, y is, why are we doing that? What order are we doing this in? We're doing, for every x, check every y. So when we get to x is 1, y is, yeah, okay, so here, y is negative 1, x is 1 and y is negative 1, right? And we should end up with, when we're done, we should end up with something like that, right? Because we're going to go to the right one, everything's going to go to the right one, and everything's going to go down 1, or it should. That's what it's supposed to do. So we'll see what happens. We go here, we go mx, and matrix right now, right, is still, it shouldn't have changed. It should be 100. It looks like it has changed. It looks like it has changed though. Right? Or no, these are different. These are different numbers. So let's try it with. Let's try it with these. Let's try it with this test case. So then we get here, x equals 1, y equals -1. Right, we have that. It is 110, 010, 010. Yes. Okay, and it should end up like that. 000, 011, 001. Okay, so we go here, and then this should end up. Where are we? Ah, ha, ha, no. I want to do that. Count as 1. Why? What do we have here? We have, instead of, okay, no, that's right. We have 000, 011. No, that's right. Right. No, that's right. It should be, this is pointing to, or no, where's, no, it should be, because those are going to be the same as mx2 we were looking at. We want mx, where's mx, no, that is mx trans, right? MX trans is pointing to a list with only one listener. Why is that? So MX is then pointing to that. Huh? Why is it pointing to a list with only one row? What did they do? It said plus how did that happen? Now you're in here. So MX is pointing to that. Which is not. How did that just change? Oh, thank you. Software and game development category. Very cool. I'll definitely do that next time. I will mark my stream as software. Thank you. Appreciate it. I appreciate the heads up. Um, so I'm not sure what is causing that to happen though, because we are going from that. Which why is that not changing also for row and mx? What if I just try? Let's make this a little more simple. We'll say mx. Instead of doing that, I'll just say we'll test just the translating for now. For to begin with, we'll say matrix translate m1, and we'll do it. Then what we want to do is to the right one and down one. So we'll do 1, -1, 1, -1, and so we go in there, right? So we have M1, and then when we want to translate, we're gonna say for every row, so we want to make a copy here. So we deep copy it. So every row we want to shift over one to the right. So it's a little weird to see because they just kind of put it wherever, but this is the first row, so that should get one shifted over, one to the right. Right. Oh, but did I not save it? Is that what the problem is? Did I not save it? So then it's 0, 0, 1. It worked before when they did something like that, though, didn't it? Then return mx. Okay, then this is the weirdest part to me. Why is it just returning that then? Mx should still be. Okay, so I did something a little different, right? Before, so I appended. I think what I did was no, because mx is definitely the whole thing, and then all of a sudden, it's only. Um, or you know what? What if it? I think I might got an idea. I think I might know what this. Is it like this? Do I need to extend it like that? I think that might be the. Is that the? Turn value. thought we tested this and it worked. I thought we tested that and it worked. Did it not work? I could have sworn we tested that and it worked. Like, we're extending the list with more lists. No, they shouldn't even need this. Shouldn't need that. There's no reason I should even need that. Because MX, like 2 seconds ago, so MX is a 3x3. And then times, could it be the -1? Do I need to absolute value these? I think I need, that's probably what it is. I need to absolute value the, right? Or if it's greater than that, then that's fine, right? If it's greater than that, if x is positive, then we're fine. We don't need to worry about that. But if it's negative, then we'll come in and we'll just say x is equal to absolute value of x. If it's negative, we'll say y equals absolute value of y. And let's see, that might help, maybe. Returned. Still no, it doesn't. That still doesn't help for some reason. Y minus what? No, y equals. Okay, there we go. Aha. Okay, that appears to might have been the issue. That may have been the issue. We'll take that and we'll put it in here. Return MX we already have at the bottom there. We're good. How is it still the wrong answer though? Because now definitely we're getting, I know that it's giving me the right thing for this, right? It's returning the right translation, isn't it? We know that because we just tested it. Now, for sure it's returning the right translation. Right? If we go, so now what's the problem? We get to we need x is 1, y is -1, so that should be this next iteration, right? Right, so then we go here and we return from that return mx, and mx is 0, 0, 0. That's not right. That's not what mx should be at this point. Oh no, that's, wait. Oh, right, right, right. Right, 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 right. No, 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 that's good. No, that's good. But it's saying 0, 0, 0. That's not what it should be though. It should be um, 0, 0, 0, 0, 1, 1, 0, 0, 1. And that's what it is if you do it by itself. So is it changing? Am I changing the original somehow? Am I changing the original in the and somehow? No. I'm not changing. Why? How could it possibly not be getting the same? It should be for the one that's to the right one and down one, right? Yeah. We did that. So it's um so what's when you pass in MAT is the right one to the right one and down one. Hmm? MX is image one that you're passing in. So for the row, we go MX to the append. Alright, so we go 1, 1, 0, 0, 1, 0, 0, 1, 0. Right. For row, the row becomes, so in MX, we should be seeing the first one move over, or yeah, it should be moving over to the right 1 unit. So it should get a 0 on the front and then, yeah. Right, that should be that. but it didn't change it in the matrix. And then mx just ends up being, but wait, it ends up being the right thing. It ends up being 0, 0, 0. No, it doesn't. Oh, so it's working for, okay, I see what's going on. It's working for the y's, it's not working for the x's. Because the rows are temporary. The rows are temporary variables, so we'll say is for say I in range of the length of mx, and then we'll say mx at I is equal to that, then mx to that, and for I in range length of mx, we'll do mx at I is equal to mx at that to that. Okay. Okay, it says count as 3. Right? Or no, it says largest. Oh, cool. Okay. I think this may be the key here. This may be what we needed to do. Cool. I'll submit. Wrong answer. Why? That would give you 2. How could that possibly give you 2? Oh no. It says it gets 2, but it's supposed to be 1, but only. How could that possibly do that? How would you get? How could I possibly get 2? That doesn't make any sense. I translate it. I should never get anything other than. Yeah, if you moved it left one, you would have nothing. Yeah, that makes sense. Where are we getting to? Where are we getting a count of two? Where's that happening? Okay, where did that just happen? We had count. Okay, so we have mx1. What is happening here? Huh? Oh. Okay. Now that would make sense, wouldn't it? Oh yeah. Yeah. Okay. Yeah, no, that makes sense. Okay, so we'll do, yeah, that at I and that at I. Alright. MX at I from that onward. I'm surprised that even worked as well as it did. Just not very well. But we'll see how that goes. So that's, yeah. Okay. Right. Cool. All right. So yeah, eventually we took a little bit, but eventually we got there. That was a good one. Incremental development. There was a little optimization to do. Um, Made some dumb mistakes, but it happens. Especially when one of these takes a little while to do. Um, but yeah, I think we'll just do that one today because we've been going for a couple of hours. Um, I'm really glad that it paid off and we were able to submit that though. Um, Memory usage is okay. Runtime's still not that great, but it's submitted. So, cool. All right. Well, thanks for watching, and I'll see you all for the next stream. Maybe I probably won't do more. Maybe I don't know. I might stream later. I'm not sure if I'll do. I might do more coding, or I might do like a gaming stream. We'll see. Um, anyway, later. Thanks all for watching. Bye.